Welcome, this is the AP Physics Workbook Solutions. Here we're covering section 1.0. This is 2D motion. Here's the scenario. An engineer is testing the design of a new crossbow to try to find the speed of a dart the instantaneous it is launched from the crossbow. The crossbow is fixed to a table so that the dart is launched horizontally. Here's the table, here's the dart. A target is placed in front of the crossbow so that the crossbow is pointed directly at the center of the target. Here's the target. That's what it means by point directly in the center. The distance d from the crossbow to the target is varied, and each time the crossbow is fired, the distance h from the center that the dart strikes the target is measured. In theory, the target is right here, which is horizontally, and an object that is shot should normally go directly straight at it, but it goes down a distance h due to gravity. Okay, so here we have the horizontal distance, okay, that the target is being placed. So it's placed at 5 centimeters, okay. It can be placed here at 5 centimeters, right? Or it's not centimeters, like 5 meters. So this could be like 5 meters. Then it places at 10 meters. Then it's at 15 meters, right? So do you see how it's closer, right? If it's closer, the dart falls here. If it's further away, it falls more. If it's further back, it falls more, right? Because the trajectory, in theory, should follow sort of like a parabola, right? The second part of the parabola. And there is a time. So there is a time that is measured from the time that the dart gets shot. All right. So there are some values that we are going to calculate. Okay. So we're going to calculate the time that it takes the dart to hit this. All right. So to do that, let's start by doing part one. Using the assumption of the crossbow dart, where projected horizontally, derived an expression for t in terms of h and g. Remember that the derivation should start with a fundamental equation. So it should be one of these. Okay? All right? So we have our formula sheet, should be one of these. All right? So which one are we going to look at? We want to derive an equation for t, which is time, because that's what the previous problem is. Can we use this one? We can, right? That looks pretty good. We have an acceleration and time, okay? But this, right, is for a linear object, okay? So let me see if I have the equation out here. Nope, okay. So here, this is for a linear object. This wouldn't work. This is for a linear. It wouldn't work. This could work, but there's no t in here. This is the second one is the only one that works. Okay, so I'm gonna just put it on the side and just write it. This is how it looks like on the equation sheet. Okay, looks like this. Now, this works because, do you see the squared here? The squared, this is a second degree polynomial. A second degree polynomial does look something like this, a parabola, right? That's how you know it's this equation. But we are looking for time, okay? The object is falling up and down, so we're either using the x or the y, but we want it in terms of h. And what does the h stand for? The h, okay, in the problem is the height that it drops. So if you look at your axes, the height that it drops is on what axis? It's on the y. Okay? So this is your height. It goes from h final to h initial. Ooh, some of you don't like that. So h2 to h1. All right? So what that means is, okay, this can be written in terms of this problem. All right? It can go from height, its final height is equal to your height initial plus v, your velocity. And is this x? No, it becomes the y. So the velocity in the y direction, initial times time plus 1/2 acceleration in y times t squared. All right. Now we want to know what h is, and we want to know what ho is. So what's the initial? Okay, so you could subtract h naught, subtract h naught. This becomes h minus h naught, which just becomes delta h. Okay, or in short, can just be called h. So delta h stands for, all right, your, so on the side here you can write delta h is equal to h 1 minus h naught. Okay, if you would like to see how this becomes, right, which is just going to be equal to just h. Okay, that is just some legend for this. Okay, this equals to velocity in the y direction 0 times t plus 1/2. Acceleration on the y, we know that ay, the acceleration in the y component is always gravity, t squared. All right, and I think I have that set up here. There you go. That's what I have, and that's what I have there. Okay, so we could finish this. We know that the velocity in the y direction is 0, so this goes to 0. So you have h is equal to 1/2 gt squared. Right? Multiply by 2 to both sides, you get 2h equals to gt squared. Divide by g, you get 2hg is equal to t squared. Square root both sides, you get 2h over g is equal to t. Right? Boom, boom. There you go. All right, so we're going to use this equation. T equals to the square root 2h over g to calculate, to fill in the table. Okay, so let's just go here. I'm just going to do one of the examples. You could do the rest. Here we have the we have the equation t was equal to square root 2 of h over g. We could do the first one. Square root 2 times, what is the h here? Horizontal height that it falls, which is 0.084 over g. I'm just going to use 10. Right? Plug that in the calculator, see what you get. The square root of 2 times 0.084, 2 times 0.084 divided by 10. Let's see if this is what I got. Okay, I got this equals to 0.129 approximately t. So I'm going to round to 1.3 seconds. Okay, does that work? Yep. Okay, so again, repeat this process. Pause the video if you would like to do that. But here it is. All right, this is simple. This is very simple to calculate if you remember this. And again, this equation is useful. This is universal. This equation is used, right, this is for the time of an object, right, that the time of an object that undergoes a parabola motion. So, but this is only for horizontal height. Okay, because if you want to think about this in terms of like function notation, right? If you want to think about this in terms of function notation, you could really think about it as this. It's a function of height, or the drop height is equal to the square root 2h times 2 times h. This could be, let me make this small h to not confuse you. So 2 times h over 10. Okay, that's how it really looks like. Okay, if you really want to think about it mathematically. Okay, so this is math. Okay, if you're a pure math person. Okay, all right. So let's take a look here. So what quality can we set up to graph it so that we can figure this out? Okay, so we know from our motion graph, right? Right? From our motion graph, time should always be on the bottom. So it's either distance, right? It can also be velocity and time. And we also know what? It can be acceleration and time. All right? But what they're trying to get you to understand here from this problem is that you're trying to create a line of best fit, right? If we just graphed, if we have just graphed this, let me show you here. If we have just graphed this, we had what? H was equal to 1/2 gt squared. We had this step, right? If you would graph this, do you see how this is a squared? This is a second power. If we graphed it the way this is, if we graph this right here, it would look like something like this. Right? This is the negative stuff. We don't want that. We want it to be what? A linear trend. So we want a value so that the both sides will create a linear line. So here is a potential answer. Okay. The vertical axis is your horizontal distance. So that's what we talked about it here. Right. And your y-axis, your x-axis should be your time, right? So this just becomes your distance, but in the horizontal. And it does work because, again, if you think about the equation that we wrote down, time is equal to the square root of 2 times h is over 10, basically, because this is what g was. All right? In simple English, in simple math, imagine the input is time and the output is the horizontal distance. Okay. Mm, this is phrased wrong. This is distance dropped. Okay, that's the distance dropped by the dart of the crossbow. Okay. All right. So here, I know that this is my time, and I saw this based on the graph. So, and then my horizontal distance is this way. I'm going to put a side note because this is what happens on the AP test. Okay, this is the way they will also grade. Please understand that if your graph looks like this, okay, let's say your scale was from, let's say, here's 1, right? And this is like 25, right? Um, no, this is like 5, and this is 10, 15, and this is like 25. No, 20, and 25 is up here, right? Do you see how it will look something like this? Right? Do you see how the scale, based on the scale, based on the scale, the graph only covers like what, maybe 25%. So they're not. This is a bad graph. This is a bad graph. Okay, you want to scale it out properly. So you want to have to look at the range of the values and the domain of the values. Okay, if we look at our chart, All right, let me go back. Think about this. This is the our inputs were essentially this, right? Our input was our um, was going to be the value that the height dropped, right? So let's take a look. Okay. So the values that you want to have in this problem, okay, was your time. So this is your lowest time, and this is your highest time. So you want your domain to cover all of this. This is the reason why they started at 0 and it goes, do you see how it's 0.45? They go to 0.5, all right? And your range was this, the horizontal distance of the target, okay? All right, that was being shot, all right? So here we have the lowest value and it goes to the highest value, all right? So that's why it goes from 0 to 5, all right? So that should give you a better reason for why it's set up that way. And once you graph the points, it should look something like this. Okay, do you notice how this graph covers the entire graph? So this is a good question. This is a good graph. All right, last one. Using this, you want to determine the speed that the crossbow launches. So we want to find the what here, the speed. And what do we know? Okay, we have the distance and the time. So to get the speed, is equal to the slope of the distance versus time graph. All right? Okay? We want the slopes here. Can we get an instantaneous? So can we get a slope here? 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 Are we finding an instantaneous speed? No. Here, I'm going to grab this point. I think I grab this point and I also grab this point. Okay? This is going to be my first point. And this is my second point. And my first point here, I think, was 0.75. Right? 1, 2, 3. Yep, comma, and this is half, so it's 2.5. Oh, 0. It is 0.075. My second point here was, I think I made this 0.375, comma 20. Okay, that's my second point. So I'm going from here. All right, I'm gonna find a delta x and a delta y. Okay, I'm going to see how much it changes. So here, I'm trying to find this change. So again, I'm actually finding the average speed here. I'm not finding the instantaneous speed. I'm finding an average because it's the slope. All right. Okay, so here's my first point. Here's our second point. That's the slope equation. You should remember that from algebra. Plug it in. Get that value. Simplify. You should get around 58 roughly. Okay, meters per second. Okay, so please understand that here, what's the point of this is I'm going to read it to you. While the rule for significant digits is not directly tested on the AP test, you will be expected to use a reasonable number in the significant digits in this calculation. That's why I rounded to basically 58. Significance is indicator of the quality of the measurement and the given variable dictated by the significance of the answer. Okay, points may be deducted for an unreasonable numbers of significant digits. So again, 58, right? I just rounded to the nearest number. Perfectly fine, perfectly acceptable. Okay. Also, what I also want you to understand from here, what you should understand that this is the average speed. Okay, how to linearize, as well as here how to how to use the equation to plug in values, how to get a chart, but also how to derive an equation. Okay, these are very crucial steps. All right, there you go. Those are all your solutions.